Right, so I'm recording this session today. So we start our discussion on time series, okay? And these are the packages that we will be needing. Forecast package, forecasting practices and principles. This is actually a textbook dati to, tapos ginawang online textbook. This is a very popular textbook. You can, let me just show that, no? Can you see guys the screen? Paki-answer nga guys if you can see the screen. Na-share ko ba?
Yes, sir.
Okay. So this is the one I was mentioning to you about yung FPP2, forecasting principles and practice. That's very easy to access, guys. This is quite a comprehensive online text on on time series. What's good is that this time series is based in R, so you can follow along. In fact, I would like you to refer to this once in a while, lalo na pagdating natin dito sa stationary, sa Arima models. That's what we're going to discuss today, Arima. There are different, methods of forecasting time series. Meron tayong exponential smoothing methods, may Arima models tayo. We're not going to discuss exponential smoothing. Our focus will be more on the more modern methods like Arima, no? Autoregressive integrated moving average. Okay, so going back to our QuantMod is also a very powerful package. We're going to make use of this also in getting data from the internet and also working with data. T-series, time series, extensible time series, of course, you know, the ggplot2. And the URCA, we're going to use that for modeling volatility, the Garch models. And Plotly is also a very powerful package for plotting. All right, so I have here some notes which I hope you'll read, guys. Let me just go through some of them. So time series analysis is it's an art really of extracting meaningful insights from time series data. So we take a look at the structure, the characteristics, and we take a look at the pattern and try to identify the pattern. And the main objective is to forecast future events of the series, so that we'll be able to forecast the future values of the time series. Okay, as I mentioned a while ago, there are different methods. There are several methods in forecasting time series. In this topic, we're going to make use of Arima, no? The box. This is called the Box-Jenkins approach. So Box-Jenkins approach, the two statisticians who developed this method, Box-Jenkins approach, and that's called the Arima. Arima means autoregressive integrated moving average. Autoregressive stands for you're using past values of the time series itself in order to model the time series. The moving average here indicates that you're using the error terms. So autoregressive, you know, the word auto means self. You're using past values of itself in order to model the time series. And moving average, you're using the error terms. No? So you generate a model and then you compute for the error term and you use that error term to predict the model. So we have here an outline of how to forecast. Of course, the first thing is to plot the data and check if it's, this is an important term, guys. We're going to really, this is a must term for us to know. Stationary. We can only use Arima and its family. Okay, we can only use the Arima model if the time series is stationary. Otherwise, if the time series is not stationary, then we cannot use the Arima model in order to predict or to forecast our time series. Okay, if the time series is not stationary, then we have to do some time transformations. Okay, one example of a transformation is you difference the data. Later on, I'll explain what's the meaning of differencing the data to make it stationary on mean, or which means you remove the trend. So what does a stationary data mean? Stationary data means there's no trend, okay? There's no pattern, okay? It's just like a random set of data. So if you plot the time series and then you notice that there's a trend, or what we call also seasonality, then you have a time series that is not stationary. If there's a trend, if there's seasonality, then that time series is not stationary. If it's not stationary, guys, we cannot use the Arima model. We cannot use the autoregressive integrated moving average model. Okay? Let me pause for a while. Is that, pakichat nga guys? So far, clear? Clear ba yung definition natin ng stationary? Ibig sabihin ng stationary, guys, walang trend, no? Hindi pataas, hindi pababa, walang seasonality. Okay? So it's just like random lang siya na walang clear pattern. Okay? So why is it important, guys, to define first kung stationary yung data natin? Kasi kung hindi stationary, then hindi natin pwedeng gamitin yung Box-Jenkins approach, yung Arima. Okay. All right. So thank you. So again, if it's not stationary, then we have to do some transformation of the data to make it stationary. Usually, pag dinifference natin yan, ang ibig sabihin ng difference, yung value at time 1 minus value at time minus 1. Kunyari, it's a daily data, yung value today minus value yesterday. So that will be one data, no? One observation. And then you keep on subtracting, no? Value yesterday minus the value the other day. So what will happen is that if you have, let's say, 100 observations, then you will be able to generate another time series, which we call a difference time series, but this time you will have 99 observations na lang. So bakit 99 siya? Kasi nag-isa-subtract mo, di ba, yung time at observation at time t minus time t minus 1, then that means mababawasan tayo ng isa. Instead of 100 observations, magiging 99 na lang. Okay, I hope that's clear. Okay? Now sometimes pwedeng hindi stationary, kasi dalawang stationary, no? Stationarity in mean and stationarity in variance. So, pag stationary in mean, ibig sabihin may trend lang siya. So, ang ginagawa doon, guys, i-difference mo lang yung data. Pag pag hindi siya stationary in variance, ano ibig sabihin ng stationary in variance? Ibig sabihin may mga volatility siya na biglang tumataas, tapos biglang tumataas ulit, bumababa, may mga peaks na matataas na masyadong apparent. Pag ganun, guys, pag masyadong yung variance siya, masyadong erratic, then that's what we call non-stationary invariance. Now, how do you address that? Para matanggal natin yung non-stationary invariance, we do log transformation. Okay? So in order to address non-stationarity in mean, we just difference the data. To address non-stationary invariance, we get the log transformation. Ibig sabihin, kunin natin log ng data, yung ln ng data. When we do that, guys, we are able to address non-stationary invariance. Okay, sometimes, guys, kailangan pareho. So you difference the log transformation. So una muna ang gagawin mo, kukunin mo yung log transformation. Okay, pagkatapos, you get the difference. Okay, to make it stationary both in mean and in variance. So we'll have examples of that. And then after that, guys, pag kunyari, nakuha na natin difference to address the trend, or nakuha na natin yung log transformation in order to address the non-stationary invariance, then we will have to check graphically, number one, and also statistically. Okay, there are tests to determine kung stationary na nga yung data natin. In addition to the plot, no? So ipa-plot natin, makikita natin may stationary ba yung series natin. Okay, we can check that using the plot. And not only that, we can use a statistical test para ma-sure tayo using the ADF test, KPSS test. This is the augmented Dickey-Fuller test, and the Krovotsky. Nakalimutan ko yung ano yung pangalan, guys. But it's a test developed by statisticians in order to check if it's stationary. Okay, so there are several tests for this. Okay, and then the next step is we're going to plot what we call this is the auto correlation function. Okay, so that's the ACF and the PACF, which is the partial auto correlation function. Okay. Now, bakit natin kailangan i-plot si ACF at saka si PACF? Okay. Once na convert na natin into a stationary data series na, we can now determine kung ano yung model natin. Remember, we're coming from sabi natin ang model natin is Arima, okay? Later on, I'll be explaining. Actually, dalawang components yan, AR and MA, no? AR stands for autoregressive, MA stands for moving average. Okay? Yung AR natin, guys, we use past values of itself to model the time series. Okay? Yung MA naman, guys, MA is use past error terms to model the time series. Okay? Yung I dito, guys, ay integrated. Ibig sabihin nun, you have to difference the data first. TS is time series. So kaya guys, Arima, no? Okay? So let's say, just to already discuss this, ano ibig sabihin ng AR? Let's say AR1, no? Ito yung mga simple, guys. AR1, autoregressive 1 model. An AR1 model, guys, means you're using the first past value of itself. Kaya nga, later on, I'm going to discuss this. Ang model na to, guys, is y sub t is equal to AO plus A1 times y t minus 1. Okay, take a look at this model, guys. Here, we're modeling our time series as a function of an average value, a mean, and yt minus 1 is the past value of yt. Kuha, guys, kunyari ang value ngayon, 50, ang value kahapon, 45, then yun yung 45, ito yun. Plus times a certain factor, a certain parameter. So this is an AR1 model. No? Okay, although i-discuss ko pa mamaya yan, just to give you a heads up, no? Ano naman ang AR2? So y sub t is equal to a constant, okay, plus, let's just use this, and then plus A2 times y sub t minus 2. Okay, ibig sabihin ng AR2, guys, you're using the log, two logs, no? LAG. Ang log, guys, yung prior value. So AR2 means you're using y sub t minus 1 yung kahapon, kung daily siya, y sub t minus 2 yung the other day. So you're using two logs, ALGS. Ito, two logs to, no? Two logs. Ito, one log lang. Okay? So in general, an ARP process, guys, is you use P logs. So we model y sub t is equal to A sub O plus A sub 1 times y sub t minus 1. Log 1 yun, no? And then plus A sub 2 times y sub t minus 2. Okay? Plus A sub 3 times y sub t minus 3 plus dot plus, okay, plus a sub, so this is a sub p minus 1, sub yan guys times y sub t minus p plus a sub p times y sub p, okay, plus a certain error term. Okay, may error term tayo, no? Alright, kita nyo guys yung AR sub p natin. So you're modeling the time series using past values of itself. So this is a mean, this is an average. And then you have A1 as the coefficient or parameter for the weight for the past value. Yesterday kung daily, or last week kung weekly, or last year kung yearly. Then this is 2 log 2. This is log 3. This is log P minus 1. Okay, and then this is log P. Bakit hanggang P? Kasi ARP, guys. Alright? Okay, so mamaya ako na i-discuss guys yung MA naman. Kasi ang MA, makikita naman natin mamaya. So just at taste guys, may MA din, no? MA1 for example. So ano yung MA1? Okay, ang MA1 guys, you're using the past values. So ano naman ang ARMA? Ang ARMA naman, combination. Kunyari ARMA 1-1, autoregressive moving average. Ibig sabihin yan, you model one refers to the AR component and one here refers to the MA component. So combination ng AR1 at saka MA1. Okay? So the general function is ARMA PQ. Okay? So notation lang guys para familiar tayo And then we have this Arima. Okay? PDQ. So ano tong Arima PDQ na to? May I dito guys, yung I here refers to the differencing. So kunyari, you had to difference the series by 1. Ibig sabihin, nag-minus ka ng y sub t minus y sub t minus 1. If you difference it by 1, then dapat 1 to dito. No? The difference here means how many times did you difference the series in order to make it stationary. Okay? So sige, anyway guys, makikita pa natin yan kung later on. I'm going to discuss that in greater detail. Alright? So sabi ko guys, ito, after checking kung stationary na yung data, then we have to plot the autocorrelation function and the partial autocorrelation function para malaman natin kung AR model ba yan o MA model or ARMA model ba yan. Okay? So, may ano lang ako guys, ang gusto ko lang sabihin na dati, ito yung process. Pero ngayon guys, mas may ano na kasi may automatic na tinatawag na auto Arima, which I'm going to teach you. Kasi mas mabilis yun, hindi na natin kailangan na visually alamin ba kung AR ba yan o MA. When I was studying this several decades ago guys, it was difficult kasi yung trial and error. Kaya pag na-plot na natin yung ACF at saka PACF, then mag-guess tayo, AR1 ba yan? ARMA 1-1 ba yan? MA1 ba yan? MA2 ba yan? And that's quite difficult, no? So, i-model mo, tapos hahanapin natin, compare natin, ano ba mas mababa? Again, AIC, BIC yung gagamitin natin until we find the optimal model. Pero ngayon guys, wala na kayong kahirap-hirap kasi may auto-arima na tayo, which I'm going to show you in a while. And then, so sabi nga ako identification of the best fit Arima model. And then, pwede natin i-forecast yung time series. And then, i-plot ulit natin para makita natin na okay na yung yung Arima model natin. Okay? Pause for a while. Any questions so far, guys? Clear ba? So far, guys, I'm sure hindi nyo pa mag-grasp lahat, Pero at least yung vague notation na to, you can always go back to this, guys. Kasi naka-record naman to at saka may copy naman kayo ng notes na to. So far, guys, clear ba? Paki-yes or no lang. Anything you'd like me to repeat there? Okay, thank you. All right, good. At the end of this session, guys, dapat confident na tayo sabihin, Arima model yan, AR model yan, MA model yan. Okay? Again, guys, let me reiterate. Pag AR model, autoregressive, we're using past values of itself. Pag MA, we're using past error terms. Pag ARMA, we're using both past values and past error terms. Pag Arima, ibig sabihin, we're using past values of itself, past error terms, and dinifference natin yung data series natin. Okay. Thank you for that feedback. Okay, so punta na tayo guys sa stationary. Okay, so I have here some notes, no? Sabi natin, stationary time series is one whose properties, mean, variance, correlation nila are all constant over time. So yung average niya hindi nagbabago, yung variance hindi nagbabago, autocorrelation hindi nagbabago over time. Okay, mamaya may gagamitin tayong data, papakita ko yung air passengers. Tapos let's plot it and you can see guys na kung yung data na yon stationary siya. No? Tandaan nyo guys, pag stationary, constant over time, constant mean over time, constant yung variance, constant yung autocorrelation. Okay? So a stationary data looks like a flat-looking series. Walang trend, constant yung variance, ano? And constant autocorrelation structure over time. And walang periodic fluctuation. Yun ang stationary data. Okay? So, ibig sabihin nun guys, pag stationary, yung plot na yan, ibig sabihin, it does not depend on time. Okay? Thus, time series with trends or with seasonality are not stationary. Okay? Hindi natin pwede ma-model yan using Arima kasi nga guys, makaka-apekto yan yung mean at saka yung variance nagbabago across time. Okay? So, another name for stationary guys is a white noise series. So, that's another name. No? It does not matter when you observe it. It should look much the same at any point. Okay? So, yung mean niya, yung average niya, hindi siya pabago-bago. Okay? In general, a stationary time series will have no predictable patterns in the long term. Okay? So, makikita natin yan guys sa time plot. Okay, so kung hindi stationary guys, anong gagawin? We will have to transform our time series. Kailangan siyang stationarized, otherwise, anong problema guys kung hindi stationary data series? Hindi natin pwedeng gamitin si Arima. Well, pwede natin gamitin yung ibang methods like exponential time series, exponential smoothing, pwede yon. But kasi nga ang gusto natin magamit dito yung Arima kasi very powerful tong model na to, yung ginamit ni Box Jenkins. Alright, so let's start guys. Start. Kasama sa, I think sa base R tong air passengers, let's access air passengers data. So let's run this. Ito muna, let's run this one by one. Okay, so andyan na si air passengers, promise pa lang kasi hindi pa natin na-view. So i-view natin guys. Let's view this. Okay, view air passengers. Ayan, so ito na, no? So you have here values. Okay? So ano ba yung air passengers? Time series siya, 144 observations from 1949 up to 1961. Okay? So this is the time series, no? Monthly data siya, 12 months times 12 years, so that's 144. Okay, so ito yan, no? Air passengers. Okay, ang haba ng pangalan guys, palitan na lang natin yung pangalan. Let's call it, shortcut natin AP para mas madaling masulat. AP, let's create another object called AP and it's the same air passengers. Okay, yan na si AP, no? And then if you view AP, yan din siya, no? Si AP, pareho lang siya ng air passengers. I just did that para mas madali natin masulat yung AP kasi ang haba ng air passengers. And then, okay, base R has this function, plot, no? Plot AP. Okay, i-plot natin siya guys. Okay, yan, no? That's the plot of our time series. Okay, if we plot it here, plot AP. Magpa-plot siya dito. Pag sa console natin plot guys, magpa-plot siya dito, no? Okay, one thing good here is that you can export this. Export, save as image, for example. Okay, copy to clipboard. Kaysa dito pag dito mo lang i-run okay, my question yata. How do you run just one line? Okay. How do you run, Aki? Punta ka lang dito, Aki. Kunyari itong let's say ito lang just go to the end of the line, no? Okay, kasi ito whole chunk, if you just want to run one at a time, so go to the end of the line here and then control enter, no? Okay, control enter lang. So paki-chat lang if that answers your question. Okay, thank you. All right. So, yan. Take a look at our data, guys. Sometimes, guys, yung plots mas maganda i-run dito sa console. Sabi ko nga, guys, we can export this, save as image, and then pwede nyo i-ano na to, guys. Kasi pwede nyo i-ano pa to you can save this as a different, pwedeng JPEG, BMP, etc. And then you can adjust the height and the width, okay? All right, so you can do a lot here. All right, take a look at this, guys. Question, is this a stationary data? Paki-chat, guys, kung yes or no. Is this a stationary data? Ang unang question, guys, laging may trend ba yan? May upward trend, di ba? Oh. So, pag may upward trend siya, so therefore, is it a stationary data? No. Okay? It's not a stationary data, guys, kasi may trend eh. Sabi natin, pag may trend, laging hindi stationary yan. So pag hindi siya stationary, oops, we cannot model that using Arima. Okay? Ano meron niya, guys? May trend siya, meron pang ano? What do you think? Meron pang? Okay, take a look at this, di ba? Parang consistent yung mga troughs dito, no? Troughs dito. Peaks here, dito sa taas na to, and troughs. Yung troughs yung mga low part, no? Peaks and troughs. So it looks like na consistent yung mga peaks and troughs nila. Kung air passengers to, 1949 to 1961, we can check, no? We can check this. Tingnan natin, ha? So cancel ko na muna to. Let me just show something here. Okay. Let's give a name to this plot. Let's just call this P1. P1. Okay, guys, I created an object called P1, and that's the plot of plot of AP. So i-run ko tong P1 na to, control enter. Oops, P1 not found. Wait, hindi ko pa pala na-run to. Run ko to, P1, which is the plot of AP, and then P1. Oh, wait. Okay, sorry, mali yata ako. Hindi pa pwede. No, kasi hindi ggplot to. Okay, so forget it first, no? Sorry guys, ha. Erase muna natin yan. Hindi pala pa pwede yan. Okay, so what I wanted to do was to plot this using Plotly. Pero I cannot do that pala, no? Alright, so question, guys. Meron siyang, balik ko dito yung plot. Okay, not only does it have a trend, it also has seasonality, no? May seasonality siya. If we check the data, malamang to baka December or November or maybe January, where siguro holidays to na nagpipick yung either Halloween or I don't know, ano ba sa US to no? Siguro December, holiday season, marami nagta-travel, kaya may peak yan. Okay? So, for example, guys, kung titingnan natin sa 1950 to 1952, if you get the average, siguro pwede pang constant yung average, no? 1950 to 1952. But if you get to 1958 to 1960, iba na yung average ng air passengers, ang travel. Okay? Kasi number of travels yan eh. So iba na siya kaysa 1950 sa 1952 yung average dito. Dito naman yung average, siguro banda dito na. So is the mean constant over time, guys? Answer, pakichat. Is the mean constant over time? Yes or no? If you split it into different data sets in different time frames, yung average ba ng air passenger travels constant? Pakichat, guys. No, correct. No, no. So pag no siya, guys, not constant mean, not constant variance kasi pag dito, guys, yung standard deviation nito, mataas na to, no? Kasi mataas na yung differences ng ano nila eh, ng yung minimum at saka maximum, no? Dito, guys, maliit lang eh. So dito, mababa lang yung variance dito. Dito ang tataas ng variance dito. Okay? So not constant mean, not constant variance, then you have a problem. You have what we call non-stationary. Okay, and how do you make this stationary, guys? How do you make this stationary? We have to do data transformation. So unang-una, how do you address non-stationary in mean? Magdi-difference tayo. Non-stationary in variance, maglo-log tayo. Okay? That's what we're going to do. Okay, so I have some notes here. If the time series has trend, guys, difference the data. Ibig sabihin nun, we're going to create a new data set. Dapat Z sub I to. Okay. We're going to create a new data set, a new time series, Z sub T. Sorry. Tama. Z sub I will be equal to Z sub T minus Z sub T minus 1. In other words, guys, yung sinasabi ko, i-difference natin. I-difference natin. Okay? If the data, if non-constant variance, then we take the logarithm. So apparently for this data, guys, kailangan natin kunin yung log, no? Tsaka kunin natin yung difference for non-constant variance. Okay? Para mas stabilize yung variance. Okay, and then what do? We take the ACF and the PACF plots para malaman natin kung anong model. Alright, so sige guys, may ano dito, may mga ano pa, how do we perform the ACF test, guys? Saan natin ginagamit sa ACF test? Gagamitin natin si ACF test, guys, pag stationary na yung data natin. So once it's stationary, guys, then we can plot already the ACF and the PACF. And then what do we use that for? Si ACF, ginagamitin natin yan, guys. Titinan natin si ACF para malaman kung MA yung series natin. Titinan din natin si PACF para malaman kung AR yung series natin. So take a look at this, guys. It is merely a bar chart of coefficients of correlation between a time series and logs of itself. Si PACF naman, correlation between, partial correlation naman. No? So ang difference ng autocorrelation, ito, correlation siya, si PACF, partial correlation. Magkaiba guys yung correlation at saka partial correlation. Ha? Okay. Alright, so may note ako dito guys. Titingnan nyo mo yung ACF plot guys para malaman kung moving average siya. Tapos titingnan natin yung PACF guys para malaman kung AR process siya. Ulitin ko. How do we determine guys if it's an AR process? Look at the PACF. Kung may mga significant spikes doon, then, I'll explain ko to in a while AR yan. And then, look at the ACF process. Kung may significant spikes doon guys, then MA yan. Kung may parehong significant ano sa kanila guys, then it's an AR-MA process, ARMA process. Okay, here we'll have an example guys. Hindi natin gagamitin si air passengers kasi gagawin kung ano niya, practice niya na. I-practice niya guys after this para malaman nyo kung how do you difference si air passengers. Ito guys, mag-create muna tayo. So we have this code. Set.seed. Remember guys, pag set ng seed, magge-generate to ng random numbers. Okay? And then pareho tayong numbers para comparable. So we're going to create an object here, ARP, and then the C is 0.7, 0.2, negative 0.1, negative 0.3. Ano to guys? Ano to? Ito yung magiging coefficients guys, no? Coefficients AR1, 0.7, AR2, 0.7 and 0.2, AR3, 0.7, 0.2, 0.1, negative 0.1, AR4, negative 0.3. Okay? So, set that seed muna tayo guys. Run natin to. Control Enter. Okay, and then i-generate natin tong ARP. ARP object na to. So, it's a list. Control Enter. Alright, so ARP na yan, ano? Yan yung mga numbers. Tapos yung model natin, guys, we're going to create an object called AR mods. And then we're going to give a list here. Okay, you don't have, guys, you don't have to understand fully this function, okay, in R. So, ang ginagawa lang nito, guys, what's the term for that? Mag-generate siya ng several AR models. Okay? It's called an Arima simulation. Ito yung function natin. 10 data points. Okay? So ano yung list? AR model siya from 1 up to P. Ano yung P natin? Yung P natin guys, 4. 4 yung P natin. Ibig sabihin, mag-create siya ng AR1, AR2, AR3, AR4 with a standard deviation equal to 1. Okay? So don't mind guys, kung hindi niyo medyo maintindihan yung ano na to, it's okay guys. Ang objective ko lang naman dito, ma-illustrate ko sa inyo kung ano yung difference ng AR1, AR2, AR3, AR4. Okay? So let's run the whole thing guys. I-run na lang natin sabay-sabay yung chunk. Run. Alright. So now, naranan natin yung function na yan. Okay, now we have 4. Okay, meron na tayong object na AR models. No? If you click this, guys, AR models, tingnan nyo ito. No? You have AR1, AR2, AR3, AR4. Okay, ano ibig sabihin, guys, ng AR1? You are modeling the time series using ilang lag guys ng past value niya. AR1 guys, pag AR you're using past values of itself, tapos 1 lag lang. Ibig sabihin, the value last period can be the value yesterday kung daily yung ginagawa natin, or the value last week kung weekly, the value last month kung monthly, etc. The value last year if yearly. Tapos itong 2 naman guys, sabi may AR2 daw tayo. 2 lags, L-A-G-S. No? 2 days ago, 2 weeks ago. So kasama yung yesterday at saka yung the other day. Kasama yung last week at saka kasama yung 2 weeks ago, etc. Ganun ang ibig sabihin ng AR2. AR3, 3 lags. No? Yesterday, the other day, and 2 days ago. Okay? Etc. So, let's go back to our model. Okay. Ang gagawin natin guys, ipa-plot natin. So partition, number of rows, 4 rows and 3 columns. Okay, 4 rows and 3 columns. Tapos again, don't mind this guys. Don't mind this. Ang ginagawa lang natin dito guys, ipa-plot natin si ACF, autocorrelation function, and PACF. Okay? ACF at saka PACF para dun sa 4. So, i-run natin to. Okay. So what do we have here? Okay. Tingnan natin guys kung dito natin i-run. Okay, let me copy this. Dito natin i-run sa sa Control Enter. Okay, yan. Alright, sabi ko mas maganda minsan dito sa console natin. Yes.
So nagkaka-problem po ako sa AR modes, list of 0 po yung lumalabas sa data.
Saan? Sa?
Yung
Anong-
AR mods po.
Anong row?
Row 109 po.
109?
Or 111, opo. Hindi po lumalabas yung data sa gilid.
Na ano ba itong set.seed na to? Naran mo yung previous?
Opo.
Dapat i-run mo to yung previous
Sige po.
natin ito. No? Asan yung option dali? Asan na yung, ito pala yan, set.seed. Okay. I-run mo nga yung buong chunk.
Okay po, sir.
Sige, tapos pakisabi sa akin
Ayan, lumabas na po, sir.
Lumabas
Okay
na.
po.
Okay.
Thank you,
Siguro, hindi mo siguro na run yung buong chunk, no?
Opo.
Alright.
Thank you po, sir.
Thank you for the question. I appreciate that. Okay, so dito na tayo, guys. Alright, so plinat natin, using that code. Okay, sabi ko nga sa inyo, guys, you don't have to really understand fully the code, no? Ang importante sa atin dito, guys, na gano tayo. Let me just ano ka to, export ko. Export as image para mas okay, with okay ako. 800, kaya ba to? In-increase ko guys yung width para kitang-kita natin. Okay, ito na lang guys. Okay. Hindi kita, no? Ito guys, yung nasa, you see this guys? So ito yung simulated data natin. This is the first series. Okay, AR1 to, AR2, AR3, AR4. Okay. So take a look at this guys. Is this series, itong series na to, is it stationary? Paki-chat nga guys. Stationary ba siya? O, mukha naman stationary, di ba? Constant naman siya over mean. Over yung 50 periods na to. It looks like constant siya. Constant mean. Wala naman siyang trend. Walang seasonality. Medyo may konting may konting sa variance. Differences in variance. If you compare this at this level, guys, yung variance mas maliit. Pero dito, hindi, medyo mas malaki dito. Pero wala naman siya apparent na napakalaking shocks, no? So mukhang constant naman yung variance. So we can say that this is stationary. All right. Ito guys, itong plot dito, that's your ACF, no? That's your ACF. This is your PACF. Okay. How do we know guys that this one, ito alam natin na AR1 to kasi sinimulate natin yung data natin. Ito alam natin na AR2 to. Ito alam natin na AR3 to kasi sinimulate natin yung data natin, no? Nag-create tayo ng coefficients for AR1, AR2, AR3, AR4. So dapat guys, pag lumabas sa ACF, PACF yan, dapat makikita natin na AR model nga siya. Okay, how do we know this is AR1 model? Remember guys, pag AR1, ang titingnan natin yung PACF. Okay, if you take a look at this PACF, notice guys na significant siya at the first log. Tapos wala na. If you take a look at the blue band here, okay, yung blue band, no? Sa number 2, hindi ito, yung 2 guys hindi hindi spike yan, ano lang yan, yung parang ano lang siya ng number, no? So wala nang significant dito, no? Okay? And then sa sa ACF guys, you have here what we call a slow decay. Okay, parang nagso-slow decay lang yung natin, yung series natin. Okay? So this is how an AR model looks like. You base it on the PACF, spike at 1, and then wala na, no? And then yung sa ACF niya, slow decay. Pag MA series guys, baliktad yan. 'Di ba ang MA series, ang tinitingnan natin yung ACF. Pag MA series to guys, spike at 1 here, Okay, this is 0. So spike at 1. Tapos yung PACF mo, slow decay. Okay. If it's Arima, guys, spikes. Spike at 1, spike at 2, spike at 3, walang slow decay. So that's how you distinguish between an ACF, an AR model, and an MA model or an ARMA model. So ganito guys dati, no? Talagang ina-eyeball natin, tinitingnan natin, and mag-guess tayo. Okay, take a look at the AR2 guys. O tingnan nyo to sa AR2 guys. Oh. Significant spike at 1, significant spike at 2, wala na sa iba. Pero sa ACF, slow decay siya. Okay, so this is a signal that this is an AR2 process. Okay, ganun din guys sa AR3, slow decay sa ACF, and then sa PACF, significant spike, lag 1, lag 2, lag 3, significant din siya kasi lampas siya dun sa blue lines guys, no? Okay, wala na sa 4, wala na sa 6. Okay? And then sa AR4, okay, ganun din guys, slow decay dito. And then dito significant at lag 1, lag 2 significant, lag 3 significant, lag 4 significant, wala na dito. Okay? So ang ginawa natin dito guys, nag-backward process tayo. Nag-generate muna tayo, nag-simulate muna tayo ng data na AR1, AR2, AR3, AR4, and then we looked at how the ACF and the PACF looks like. Okay, so far clear guys? Pause muna ako. Clear ba so far yung AR? Guys, yung AR na time series. Time series that can be modeled na AR. Clear ba? Okay, thank you James. The others guys? So far? Tandaan natin guys, kapag autoregressive yung model, yung autoregressive, how do you model it? You use past values. And then how will the ACF and the PACF look like? For an AR series, the ACF will look like a slow decay. The PACF will have a significant spike at the lag. Doon sa LAG niya. Kaya nga dito guys, again, yung AR4 natin, significant lags at 1, 2, 3, 4. No? Minsan guys, hindi siya masyadong apparent, kaya yan ang mahirap. Hindi siya ganun kaagad kaya minsan magta-trial and error. AR2 ba to? MA2 ba? Kasi sometimes it's not really clear. Kaya magta-trial and error tayo dito. But then again guys, ngayon, hindi na. Mag-auto Arima na tayo guys kasi automatically, i-generate sa atin ni R. Maghahanap siya ng iba't ibang klaseng modeling. Tapos, pipili na lang natin yung lowest AIC or BIC. So it's really convenient now. But it's important guys that we understand first kung ano nangyayari, no? Okay, yung next guys. Okay. Ito guys, this is Arima PDQ. Remember this is D difference. Now, meron ding PDQ, capital PDQ and S. This is autoregressive for may seasonality. Katulad ng air passengers, dapat ganito yung model niyan. Pero hindi natin kukunin class yung may seasonality kasi medyo advanced topic na yan. Ano lang tayo guys, we'll be contented with Arima PDQ, yung walang seasonality. Okay, so going back here, wait. Meron ba akong ginawang MA? Dali ito guys. Ito. Tingnan naman natin guys si MA. Ayan. MA, again, mag-MA1, MA2, itong dalawa, MA3, tatlo, MA4, apat. Ganun din guys, gawin natin. Mag-set.c din tayo. Then let's create an object, MAQ. Okay, and then this is the function para umulit siya. Mag-generate siya ng apat na MA series. Run natin yung chunk na to. Run the chunk. X natin. And then, again, i-plot natin yung ACF at saka PACF ng MA. No? Ng MA series natin.
Sir,
Yes.
bakit nasabi figure margins too large daw po?
Dito yan sa kaya dito ka nag sa plot.
Diyan po sa may po.
Dito? Ibig sabihin yan, kailangan lakihan mo ulit yung margin muna, tapos saka mo i-run. Or, dito na lang natin i-run para mas mas maganda. Kasi ibig sabihin nun, hindi ito. Yung plot natin, ito, tama. Yung 121 to 126, i-run natin dito. Copy natin, Control C. Dito natin i-run sa console natin, Control V.
Thank you, sir. Thank you.
Okay, thank you. And then lakihan natin to. Okay. And then Control Enter. There. Export natin. Pwedeng copy to clipboard. Yan. Okay, so ito na lang guys. Okay, take a look at our bakit AR1 to? Sorry, mali yung na ano ko. Mali yung na-plot ko. Wait. Oops, hindi ko pa na-plot yung ano. Okay, naran ko na itong MAQ, okay? Tapos, this one, I'll copy this. Control C. AR pala ito na-copy ko. Sorry guys. Control V. So ito, MA na. No? Too small. No? Figure margins too large. Okay, let's increasean ko ulit to. Ikaka-problema pag hindi kasi ano eh. Ayan. Okay. Export ko ulit. Yan, guys. Pwede natin makopy plot to. Copy ko. I can copy this in Word. Kunwari, you're creating your output in Word. Ang kagandahan dito sa when we plot it in console, makakopy natin yung plot. No? Okay. I just copy it in Word, guys, para mas malaki yung hindi pala. Right, ito na lang. Ito na. No? Ito na, yung zoom natin. Okay, tingnan natin guys si MA1. So sabi natin, how do you distinguish an MA series from an AR series? Pag MA guys, you focus on the ACF. Okay, tingnan nyo ito, MA1 guys. Significant at lag 1. And then yung PACF niya, oops, slow decay. No? Yung slow decay guys, pwedeng alternate yan. Ha? Yan, tingnan ito. Slow decay dito. Parang over time, parang lumiliit siya. Ito significant at 1, spike at 1. MA2, spike at 2, significant to. MA3, significant dito siya. Lumampas siya ng blue line. MA4, so, ano siya dito. No? Tapos yung mga PACF natin, mga slow decay siya. Nag-alternate na slow decay. Alright? So I said guys that sanay na tayo magbasa ng AR at saka MA model. Madali na to. No? Kaso pag nagsisimula guys, ang hirap. No? MA ba to? AR ba to? So sige nga, i-model ko to as AR. I-model ko nga as MA. Tapos pag minodel yan, mag-generate ng AIC, BIC. Tapos siyempre, magko-compare ka pa. Sino mas maganda? AR11, AR1. Okay? So, medyo mahirap yon. But I'm going to show you a technique for determining kung anong model nga siya. Okay, so let's go back here. Okay, so ito guys, I'll leave this for you to read. Ito sinabi ko na to sa inyo kanina. This is now this is your Arima PQ. Bakit Arima PQ guys? Okay, take a look at our model. Y sub t is equal to, you have a constant. You have this, this is an AR process, di ba? Hanggang P. Tama ba guys? AR process to. Yan natin ito. So the one here is your AR process. Kasi past values of itself, no? Y sub t minus p. ARP yon. Ito naman, guys. Okay, 3 dots. So B1 minus error term to, no? Past error term. Tapos minus, lakihan ko pa, B2 times E2 minus 2. Okay, previous error term. Okay, and then minus, dot, minus B sub Q. So that's your log order, no? Times E sub T minus P. So this is your ARMA PQ. Combination ng AR process, P logs or order of P, and then MA order of Q. So kunyari, ARMA 11, guys, how will that look like? Sulat na lang dito natin para ano. Sulat ko ba sa ilalim nun? Ito pala, guys. No? Wala ditong okay, so, meron dito. So ito, guys, winrite ko lang dito yung general form. Okay, an AR1 process is equal to an Arima 100 process. No? Assuming na hindi naka-difference to, ha? Kung naka-difference yan, dapat Arima 11 yan. And it's the same as ARMA 10. So what does that look like? A sub 0 plus A sub t times 1 minus t, 1 plus the error term. AR process with a mean of A0 plus a log 1 of its own value, A sub 1 times Y sub t minus 1. Okay, so this is just a repeat of what I discussed a while ago. And then you have your MA process here. No? So MA, E sub t minus E sub t minus 1. Okay. May kulang pala ako dito kanina, guys. Sorry, ha. I forgot here. Okay, I forgot here the plus. May error term yan. No? Sorry. Plus error term. Ito plus ET. No? I forgot the E sub t here. An AR1 process will always have an error term. No? AR2, hindi naman kasi exact model yan. Okay. So, naranan natin to, no? Alright. Okay na tayo dito. Okay. So dito, guys, Arima 111, anong ibig sabihin ng Arima 111? Take a look at Arima 111, guys. Order 1 ng AR process, order 1 ng MA process, and then we have this 1. Ano to? Difference data. That's why, guys, ang series natin, hindi na Y sub T. Kasi iba na yung minomodel natin, ha? So it's now called your dy sub T or your Z kanina, no? Z sub T. So if I replace this by, if Z sub T is equal to Z sub I is equal to Z sub T minus Z sub T minus 1. So dito magiging ano siya, no? Your Z sub T, kasi panibagong series na, will be A sub O plus A sub 1 times Z T minus 1, then minus B sub 1, A sub T minus 1, okay, B sub T minus 1. So this is your, this is your Arima 111. Okay, pause muna ako, guys, kasi I'm sure yung medyo nakakalito din to, no? Okay, pag may 1 dito, pag may difference, notice na iba na yung time series na kino-consider natin. Hindi na yung original time series. Kasi pag yung original series, guys, then we revert back to Y sub T kasi ito yung original series natin, eh. Pero pag dinifference natin, then we're actually using another time series. yung minus na natin. Okay? All right. So this will okay, I leave this, guys. I leave this exercise to you, no? Okay, ito guys, i-run nyo to. Ang gagawin natin dito, sige, okay na to. I-run natin to. Ayoko na i-skip. Ito na guys. Alright, so we have here, mag-simulate tayo ng 500 observations guys, ang AR1 process and MA1 process. No? Dito should be A1 and should be A1. Okay. Guys, may mga condition tayo ha. Yung AR1 process natin, yung value ng A1 should not be greater than -1 at saka +1. May value, may bounds yung A1 natin at saka yung B1. Hindi pa pwedeng tumaas yan ng more than 1 at saka greater than -1 or less than -1. Ibig sabihin, -1.5. Okay? Kasi magkakaproblema yung AR1 process natin. Kung yung A1 natin, naalala niyo A1 ano? Diba? A sub O, yung AR1 natin is A sub O plus A sub 1 times Y sub T minus 1 plus epsilon sub T. No? So, ito lang ha. Remember our AR1 process? Just for you to recall. Ano siya, no? Y sub T is equal to A sub O plus A1 times Y sub T minus 1 and then minus B1 epsilon T minus 1 plus epsilon sub T. Yan. So that's your AR1. Sorry. Ano to? That's your okay, so this is your wala to? This is our AR1 process. Ang sinasabi dito, dapat si A1, dapat hindi siya pwedeng greater than 1 at saka less than -1. Hindi po pwede. Ganon din si MA, guys. Yung B1 dapat may bounds yan. Okay? The coefficients of the AR1 and the MA1 can't be greater than 1 and less than guys, sandali ha. Just quick. Okay, sorry guys, apologies. No? All right, so what's happening here? Okay, so M1, then nag-set seed tayo, no? Then we have AR1 dot small. This is an object. Magsa-simulate tayo no magsa-simulate tayo ng AR process. model is equal to AR. Okay, then yung ano natin, yung ano natin, yung coefficient natin, yung A1 natin, it's 0.1, okay? Then ipa-plot natin si AR1 small. Nagpa-plus M tayo dito para yung so yung value ng AR1 small natin, okay, we have a small coefficient 0.1 tapos plus M, so this is whatever the value here is, magpa-plus 1. Sige, ano natin, i-run natin ito muna. Run muna natin to. So para ma-plot siya. Okay, hindi naman kaya. I run it here again, guys. Okay, there. Okay, take a look, guys, at the AR, at the plot that we do, that we have here. So this is an AR1 process, guys, kasi nga nag-Arima simulate tayo. And we have the AR, ang list AR is equal to 0.1 lang yung value ng AR ng A1 natin. So it's a small value. So nakikita natin, guys, it looks like this, no? 500 data points, okay? Coefficient natin is 0.1. And then here, yung ginawa natin dito, nag-forecast, Arima tayo. Okay, i-run nga natin to, guys. Copy ko na lang dito. Okay. Take a look at this, guys. So, ginawa natin, nag-forecast tayo. Okay. Si Arima, AR1.small, yung ano natin, yung model natin. Pina-run natin, guys. This is the code, Arima. So, ano lumalabas? Ang sabi dito, guys, it's an Arima 100. Okay. Ang coefficient niya, AR1 is 0.1873. Okay, kanina, di ba, 0.1 yung pinagamit natin. Pero ito yung minodel niya, 0.18. Not far naman. Okay, so this is the result, guys, of ginamit natin yung object natin na AR1 small. Okay, ulitin ko lang, ha. So nag-create tayo ng time series na AR1 small. Okay. So ito yun, AR1 small. Where's that? Ito, AR1 small. Bakit small siya, guys? Kasi yung ginamit natin na A1, yung value ng coefficient is just 0.1. Okay, what about, guys? What about what happens if the coefficient is greater than 1? Okay, so yun ang gusto kong pakita dito, no? Wala na. Wala yung cursor. Ito muna tayo, guys. AR1.large. This time, ang gagamitin natin na A1 is 0.9. Pwede pa ba yan? Yes, kasi dapat less than 1 siya. Okay? Dapat hindi siya tataas sa 1 o hindi siya bababa sa -1. Between that range. So let's call it AR1 large kasi almost 1 na yung yung coefficient natin. Tapos i-plot ulit natin. So let's run this. Natin kung kakasya dito. Control Enter. Kumasya ba? Hindi naman kumasya. Control C. Control V. Control Enter. Yan, guys. So this is now your AR1 large. Okay? Papansin natin, guys, mas malalaki yung yung fluctuation pag AR1 large compared to, balikan ako si AR, wala. Dapat nandito si compared to AR na yung 0.1 lang, mas maliliit yung fluctuation nun. Okay, so hindi ko na iraran siya, guys, in the interest of time. Okay. Pause muna ako, guys. Clear so far ba? Summarize ko lang, ha. Minomodel natin si AR1. Sabi natin si AR1, dapat yung A1 nun, ang rule niyan, dapat hindi siya, thank you, Ernest, dapat hindi siya lalampas ng 1 o hindi siya bababa ng -1. Not more than 1, not less than -1. Okay, so nakita natin na if A1 is 0.9, mas malakas nga lang yung mga fluctuation. Pag A1 is 0.1, mas maliit yung fluctuation. Now what about, guys, kung yung A1 natin, okay, ito, guys, nga pala, i-run natin to. Let's run this. Yung sa large, no? Okay, kita nyo, guys, in-estimate ni, it's an Arima model daw, Arima 100. Okay, based on the data, generated data, and simulated data, ang niya, ang sinabi niya, it's an Arima 100, tapos AR1 0.86. So malapit dun sa 0.9 na sinimulate natin. Okay? Now what happens, guys, if the coefficient is greater than 1? So gawin natin to, AR1. Ito ginamit natin, guys, 1.01. 1.01. What will happen, guys, kung isa-simulate natin yung Arima, pero yung AR1 niya is 1.01. So let's run this. Okay, ano nangyari, guys? Ano sabi? Ano sabi, guys? Yan, hindi pa pwede, no? Hindi pa pwede. Nag-stop siya. Kasi, guys, kapag AR is yung A1 dyan is greater than 1, then it's no longer stationary. Okay? So pag hindi stationary, guys, hindi pa pwedeng mag-Arima. Okay? So yun ang gustong sabihin dito. No? Ganon din dito, guys, sa AR2. I'll leave that, guys. Kasi magta-time na tayo. AR2 at saka MA2. So pakigawa na lang nito, guys. Paki-run and try to explore it. No? Dito, yung 2. Let me just show to you. Si AR 0.9 at saka -0.2. So pwede yan. No? -0.7 si AMA at saka 0.1. Okay, clear so far, guys? Pause muna ako. Okay, I'm satisfied with our pace. Marami tayong na-discuss ngayon. Okay. Now, ang encourage ko kayo, guys, na i-practice na to, no? Hindi naman talaga makakuha yan ng isang sitting lang. So you have to practice it para yung ano natin. Tutuloy natin to next meeting. We'll continue with this next meeting. Okay. Practice niyo para maging mas conversant kayo dun sa ano. Clear ba so far? The rest, guys, I'd like to see your feedback. Ito pwede. Kung okay naman. Any questions ba so far? Okay. Thank you. By the way, guys, sorry, nakalimutan kong tanungin kung kung okay lang ba na i-record ko yung we were instructed to ask that beforehand. Based on prior sessions, you wanted me to record it. So I hope okay din pa rin to. So is it okay, tatanungin ko na guys, is it okay for me to post this sa natin, sa Canvas natin? Kung recording na to? Okay. Otherwise kasi, hindi ko siya i-post. Okay, thank you. Okay, now we're going to, combination to guys, ang practical application. There's a powerful package called QuantMod. No? Inuna natin to. We installed this and okay, na-install nyo ba guys? Nga pala. Yung required packages guys, si QuantMod ito, no? Very powerful to. Na-install naman natin, ano? Nag-library tayo. Okay, let's go there guys. Nasa row, ano na tayo? Okay, row 272. Okay, let's, sa QuantMod package guys, we can download, no? Download the several stocks. Okay, so the code is get symbols. So let's download Apple. Let's use 2014 January 1 up to December 31, 2019. So sige muna guys. Let's get symbols. Okay, Control Enter this row. So this is how we download data from using QuantMod, no? The get symbols. So if you notice, may Apple na tayo dito, AAPL. Okay, without us going to Yahoo Finance or nada-download, no? Basta alam lang natin dapat yung ticker symbol niya. Then view. Okay, so we now have our Apple here. And dito yung open, high, low, close, volume, and adjusted. So this is daily data. Kasi sabi natin from 2014 to 2019. No? And let's call this data AAPL para ang hirap mag-capitalize pa. AAPL. So we have another data AAPL there. Let's do this. Pareho nga siya. Do natin. Okay, si AAPL, ganun din, no? Ganun din. And then let's take a look at the structure. Okay, so if you look at the structure, guys, it's an extensible time series, XTS data. Okay, hindi pa natin napag-aaralan to, pero ngayon sa time series, simulan natin tingnan ko, XTS na to, ha? So you have only one data set here. Okay, a open, high, close here, etc. Okay. From Yahoo to, no? From Yahoo. And then you have here POSIX CP format. So we have here the year, the month, the day, and even the time. So ganoon guys yung panibagong time series, panibagong data type yan, no? POSIX CP time series yan. Okay, we're going to learn that in greater detail as we move on. Okay. All right. So yung Apple natin, guys, yung Apple natin consisting of open, high, low, etc. I have a few more minutes, guys. Ang kailangan natin, guys, pag nagmo-model tayo, especially forecasting or time series, ang kailangan natin lagi yung adjusted. Tandaan nyo yan, guys, sa research nyo, kanyari mag-time series kayo, always use the adjusted. Kasi adjusted, that is, ang ginagawa sa time series, ina-adjust siya for dividends, for example, for stock splits. Now, importante na yun ang gagamitin kasi nakaka-affect, guys, sa value ng stock yung adjusted. Okay, kung titingnan nyo, guys, dito yung close, 19.75, ito, 17.62. So, something happened here. So, it's not right to choose the closing price, but rather the adjusted. So may mga nangyari dito, may kaganapan, no? Kaya iba yung closing price sa adjusted dito. Okay? So what we're going to do is we're going to extract only the pala yung class na to, guys. Hindi ko pa na-run to. Class, you have this XTS or the zoo zoo object. Itong zoo guys, time series din yan. No? X is extensible time series. So mahirap kasi guys yung data na time eh. So that's why we have to we cannot use data frame or table. Dapat ang gagamitin natin yung mga XPS na time series in data. No? Okay, so ang gagamitin natin guys, let's create this object Apple, AAPL. Let's include all the rows, but column guys, remember this is for subsetting. Ang gagamitin lang natin yung 6. Ano ba yung pang 6 column? 1, 2, 3, 4, 5, 6. Ito adjusted lang. So let's create an object na ang laman lang yung adjusted. Hindi naman natin kailangan yung ibang columns. No? Okay, so AAPL, ano? So mapapalitan yung AAPL na object. Magiging isang row na lang siya, yung 6. Okay, run. Okay, yung AAPL natin. View natin. Okay, so isa na lang guys. No? Isa na lang. AAPL.adjusted. And let's change the name. Gawin na lang natin ADJ na lang. So this one, column names ng AAPL. So this is, yung code natin is C adjust. So ibig sabihin yung column name ng AAPL, isa lang naman yon. AAPL, isa lang column yan. Palitan natin ng adjust. No? Right. So if you take a look again at AAPL, yun, napalitan na, naging ADJ na lang para mas maiksi yung column name. Alright, it's already time guys. Okay, so we ended here, no? Lagay ko lang dito. Lecture on January 18 ended at this time. Okay, so next meeting guys, we're going to continue this. Okay, para hopefully, ang goal natin, tapusin natin to. Para marunong na tayo ng Arima. No? Marunong na tayo ng Arima, marunong tayo ng... And then from there, we'll have a little more examples to gain familiarity. And then finally, ano na tayo, yung magagards na tayo. Then babalikan natin yung ibang lessons natin. Alright, any questions guys? Did you learn something today? Paki-chat na lang kung may natutunan naman. Paki-review guys itong ano natin, itong file natin, yung ARMA, Arima. Yes, thank you. Thank you, Kat. The rest, sana may feedback kung may natutunan naman. Okay, thank you. Good. Good. So hopefully, pag ganyan, medyo may confidence na tayo sa AR process, MA process, ARMA process, Arima process. All right. So sige guys, I'll end our discussion now. Yung na-late pumasok, see me guys. Stop ko na yung recording. Thank you.